Good afternoon, everyone. My name is Mark Wong. I'm here to talk about an adventure in data modeling. I'm curious how many database folks are you application developers? Okay, all right. So I'm gonna talk about this adventure this company had about the database data model that they were using and this thing called the entity attribute value data model. EAV just rolls off the tongue so much easier. The problems I ran into and some of the workarounds. There's no single one solution, but I think there are a number of workarounds that people can live with if they are stuck with this data model. Otherwise, please interrupt and ask questions as you please. So just briefly about myself, I am employed by a company company named EDB. They sell and do full services for Postgres. I contribute to Postgres here and there in the community. Just mention if anyone else is local, I help organize some of the meetups around Postgres in town, and I help out at this little regional nonprofit called the United States Postgres Association. So anyway, what I'm here to talk about is just to tell a little story around the experience of a data modeling, a particular data model that was used for a marketing company that was storing that marketing company who has a database with their customers' members' information. I'm going to focus on the type of information that revolves around what they were keeping track of individuals. So I'll go over how they implemented the EAV data model, how they lived with it, and share what was learned. So hopefully no one has to experience the same troubles that they did. And as a little bit of a spoiler, the moral of the story is don't try not to be too hasty at implementing this thing. So the customers had data on individuals, on people, and some examples are their email address, first, last name, and just to keep it simple, we'll just say they're keeping track of what their favorite database is. Once upon a time, the way that their application was set up was to horizontally partition the database by customer. Every customer had their own set of tables. Nice, clean way to separate data. Some numbers around this is that this ended up being more than a dozen tables per customer, and only one of these tables actually had information of each customer's members, but that's only, we're just focusing on that for the purposes of this story. So with one table that contained all of their members' information, pretty easy to export information. One of the common things that customers did is they wanted to export their members' information so they can do whatever they needed to with the data. Something pretty simple. This table, what this table looked like, column for the email address, first name, last name, what their favorite database is. And in Postgres, you can use this copy statement to just dump things out into a CSV file. Very easy, simple spreadsheet sort of thing to do. And for the customers that had even millions of rows of data, millions of people's worth of data, you could expect this to get a spreadsheet in seconds, a matter of seconds. So it doesn't sound like anything is wrong with that, right? The thing that's unfortunate was that other aspects of the system was under a tremendous amount of stress. So there were already 40,000 customers. You do some math, simple math, I think. You ended up with over million of objects of the system. After you count up all the tables, for all the customers, and then all the indexes on top of that, and various other objects in the database that just need to exist. It was very hard to mine data, generate company-wide reports of what's going on in the system. I'll give a simple example of that coming up. And a couple of the administrative issues for that I think some of the DBAs might recognize was that if to add another attribute, if they also wanted to track what my favorite movie was in addition to what my favorite database was, being able to make that kind of update required an alter table statement, and I'll talk a little bit about that more later. And being able to do a database backup in a reasonable amount of time became very difficult. So how difficult was it? If we wanted to do something as simple as how many people are in this database, you would think that just being able to go through and count all the rows should be a very simple task to do for the database system. So with 40,000 customers, you're grabbing a lock on each table, which is 40,000 locks. And I'm going to see if one of these DBA folks here will help quantify this a little bit better for me. 40,000 locks is really a crap ton of locks in the system. Something that is reasonable, to give you an idea of what is reasonable, a complex reporting database, you might do a join between, say, 6 tables. You get a lock for each table, and you're looking at maybe tens of locks. And now we're talking about 40 tens of thousands of locks on a system. That's several order of magnitude different on what a normal complex query is compared to something that's simple. If you want to do something more complicated than just count the number of rows in the system, you do a join with another table. You're looking at 40, now you're looking at 80,000. You had one more table, you're looking at over 100,000 locks. It's not something that a database system, any database system, can readily manage. So it was virtually impossible on a live system to be able to do something as simple as count the number of people that are in this database. Database backups was also incredibly painful. How many folks think that 1 terabyte of data is a lot of data? So with 1 terabyte of data, I wish I did this math before because I'm terrible at doing this off the cuff now. 1 terabyte of data, you should be able to write that out, make a copy of that. How fast are drive these days? You can write several hundred megabytes a second. Should be able to copy terabyte of data in a matter of minutes. Yeah, is my math okay? So because of how many objects are in the system, the amount of locks that the system needs to create, if you were to run pgdump and get a copy of the data, it would take more than 24 hours. Now we're talking hours instead of minutes. You know, it's 24 hours, 36, 4,000 minutes. Let's say, I like to round up. Several order of magnitude longer than it should to copy out 1 terabyte of data. But, you know, on one hand, maybe that's okay for some companies. Depends on what your requirements are. If you only could have a granularity of backups for every day or two, you know, maybe that's okay. But I think it's kind of ridiculous that it takes that much longer to pump out what a lot of people consider actually a small amount of data in the system. So someone decided that it was time to do something very dramatic. Just to highlight only a few of the major design changes that were happening. The first thing that they wanted to attack first was we got to cut down the number of tables in the system. So instead of creating a partition create a new partition anytime there was a new customer, they decided, well, we'll just have a fixed number of partitions. We'll create 1,000 partitions and just redistribute all the customers with some scheme in mind, such that we're going to try to average the data out between each partition, so that now each partition should be about 1 gigabyte of data. There was some homegrown Python middle layer that was developed that'll go into a little bit more in some of the issues that have come up in part of this redesign. But we wanted to point out that there was a little bit more that this middleware layer was trying to do some things outside of the database with the intent of reducing some of the load on the database. And I'll try to explain that more in a little bit. Then probably the biggest thing is that the EAV data model was applied to the one table that was holding all the member information. So, how many folks have heard of this EAV data model before? I think Wikipedia. I don't think I can do much better than explaining it than Wikipedia. So the EAV data model is describing entities. In this specific case, an entity would be a person, an individual, and also be able to help you model attributes of that person. So name, favorite database, favorite soft drink, whatever you can think of, height, weight, whatever it is that you really wanted to keep track of. And the model allowed you to basically track as many things as you wanted, even though the reality is that maybe it's only half a dozen things, a couple dozen things, even a couple hundred. And I thought it was kind of interesting that some other areas I like to call this an object attribute value model or a vertical database model. So in case you might hear this called by a different name, because it's important to shy away from it. So I like to cover some of the other names. I always think it's kind of fun to look at ER diagram, entity relationship diagrams for database models, because I don't feel like I see them enough. How many folks get to work with ER diagrams? So what this is basically showing is the three table model. The tables are the squares and the diamonds up on top. So one table would be the entity, another table would be the attribute, and then the value table in the middle is I'm drawing a blank, a relation table between the other tables. And the circles are describing what the columns are in each table. So for the entity being representing a person, you have some kind of ID for the person, and then things that are really just help you identify the person. So an email address might be a good unique identifier, and then another reference to a customer ID, which will be a key to another table that isn't necessarily part of the three tables used for the EAV model. The attribute table on the right side has the columns that are associated with that same customer, the attribute name, such as the first name, last name, favorite database, and the type of value it is. One thing that I think some database folks that might think is kind of awkward is that the type of data it is usually baked into the column, but the way that this is kind of self-describing itself, you have to say what kind of data it is, a string, a number, a date kind of description. For the value table in the middle, where you have a column for every data type that it might be, so that you can store the data type properly of whether it's a date, a number, and so on. So this is considered a simple data model. So a couple things that were known before getting into this data model was that it was simple. This is considered simple, even though we're adding three tables into the system when there used to be one. But we just removed 39,000 tables. We can add back 3,000 tables. In the point of view of how many tables are in the system, that's actually a pretty good trade. So one of the one of the things that they wanted to get away from was having to run an alter table statement to add extra attributes. If I want to start tracking a birth date, you have to run an alter table command on the old data model to add a date column. And this is considered a expensive, heavy thing to do because you need to grab a big lock on the table, and while you're updating the table, nothing else can go on the system. And these, if no one was really using the system, it wouldn't be a big deal. But if there's a lot of activity going on, this kind of heavy lock starts, from the user's point of view, will feel like something slow. Things that were taking seconds might take minutes, usually painful from a user's perspective. So this data model allows you to use much lighter weight statements, such as an insert, update, delete, if you want to add a birth date, remove it, add another kind of attribute to keep track of. So these were all positive things that they were looking forward to in implementing this data model. A couple of cons that they realized before using this data model that they felt were things that they could live with. You need to query the data differently. You can't just dump the data out. You need to do some kind of data transformations in order to get that data out in a format that looked like a spreadsheet. I'll show a visual example of that coming up. And this is related to one of the points I showed earlier about having to write that, about adding a Python middleware into the system. And on the previous slide where I was showing all those columns were the data types, one thing that's a little awkward, I think, from a DBA's perspective, is having all those extra columns that you are not going to use because you want that strict data type checking. A date goes into whatever column is supposed to hold the date. A number goes into whatever column holds a number. The only alternative to that is to actually have multiple tables instead, but the complexity of joining to the table with the right data type is actually, I think, is actually more complex than having the one table with a whole bunch of columns that you may or may not use. So in the other point I wanted to make about this, knowing what was going in, was that you'll see soon enough that not enough was known before getting into this EAV data model. So this is how the data looks, and on the bottom is what we had before changing the data model. You had one row per person, all the attributes, everything that you were tracking on a person in a single line. With the way this EAV data model with its 3 tables, if you're just going to pull the data straight out of it, what you get is a row per attribute. So you get my first name on one line, you get my last name on another line, and everything else just continues to be on one line after that. So I'm kind of curious. People think that looks okay? Doesn't give anyone heartburn or anything like that?
Yeah, but I guess it depends on your use case. If you have a lot of columns that you need to define arbitrarily all the time, it might be the best.
Yeah, right.
Well, I just looked it up.
Uh-huh.
This can have up to 1,600 columns on a table, approximately.
Mm-hmm.
So unless you had over 1,000 possible attributes, it doesn't make any sense to do this at all.
Well, unless you don't want to run DDLs all the time.
Yeah. Right. Yeah. That was really the biggest pain point, running the DDLs all the time. If you had that 1,000 columns and you only had to do it once ever, as soon as you start doing changes.
Yeah. Because the question, I guess, is like, how much do you actually change the amount of attributes you have? Because even if you have to do like add a table or add a column like once a month or so, like that's probably affordable if it saves you all of your queries being more complex.
Yeah.
The question I had is about like numbers of tables is like, is there a reason not to have a table for attributes whose values are dates, and a table for attributes whose values are this type? You have to know when you're making your queries which tables to join. That is complexity. but as a result, you don't have this sort of like union table where you have like a table with a row, a column for every possible consumable data type. You get like theoretically you less columns in your tables, and maybe you can even index them better because you know that like, well, everything in this table is going to have a date, so you can index them as dates. You know, there are trade-offs there.
Yeah.
So, I guess, how big of an issue would it be if you had like a table with 16, 100 columns, and almost all of them have nothing in them, like if it's a sparse table? Because like the EIV might make more sense if it's otherwise very sparse.
Yeah, it looks cleaner, more compact for sure, right? And I don't know how many tables have you guys seen with even 1,000 columns in it? Never? Well, yeah.
So, I think that
Yeah.
I missed the reading, but is there anything about the write patterns? Because like, how's the data coming in? How is this?
Oh, I'm sorry. I don't think I actually caught everything.
Was there anything about the write pattern? Like, how's the data coming in, and how did the schema changes affect that?
Yeah.
Oh, I should have mentioned this earlier. If you could repeat your question.
Oh,
then,
okay.
for the people.
So the question was about the write patterns, the data coming in, how often they were changed. That really varied by customer. Some were very active in. I'm trying to think of the right way to put it. I'm trying to think of actually concrete examples because I think I might be able to do that a little bit better. Okay, I'm gonna come up with some that might not, hopefully it will make some more sense than not make sense. The most extreme ones would be like if someone was doing a book club 1 month, they want to know what everyone's favorite book was. Next month, now they want to know what everyone's favorite movie was, and if there was something new every month, every week, every 2 weeks, then those were the ones that were the most active in, I need to start tracking this. What their favorite book was. Did they like these other authors? Well, what kind of genres they like. There were probably some that were very stagnant. I think stagnant is probably not really the right word, but they always had a very small set of stuff that never really changed, and so that's kind of how it varied by customer. So the ones that were coming up with new things, what the movie of the week was, the book of the month, and so on, those are the ones that experienced the most pain because those were the ones that were doing the most table statements. A combination of that and a combination of having large number of members that they were keeping track of, which will, I think, starting to get into here.
Sorry, did you consider a columnar store paired alongside?
I don't believe so. I personally got involved when this was well in the way, and I think I wouldn't be surprised if it came up, but I don't remember hearing too much discussion about whether a column store was an option that they were getting involved in. All right, any more? Okay. Yeah. So when I started looking at what were, sorry, trying to think of how I was trying to put this. When we're trying to look at what was kind of the important statistic to look at and trying to wrap our heads around why this was behaving so poorly, how do we start looking at this to attack? When we look at our biggest customers, we see that some had, 1 million people that were tracking, a couple million people, or not quite 1 million. The number of attributes that they were tracking varied from 50, 100, 120. But what seemed to be the way to rank them when we're thinking about big or small was how many rows each of these actually produced when they were dumping data, how many rows were really coming out of the system. So what we considered large here was whatever combination of members and when you start doing the math for the number of combinations and rows are coming out, we're looking at 120 million rows ish were very painful. Who would like to gander make a guess at how long these exports took when they used to take on the order of seconds. Anyone want to shout out a number?
45 minutes.
45 minutes? Anyone else?
10 hours.
10 hours. All right. So, so this was a huge problem. No one could get their data out after I should say not no one. All of these customers with a significant number of rows that were suddenly being generated could not get their data out of the system. Anything from the type of knee-jerk reactions that were going on. We were seeing the database was timing out on running the queries to pull the data out. So got rid of the statement timeouts. Then we see the web server, as a web app, we see the web server timing out because now those HTTP requests were taking too long. Even in the data center, these network switches even have timeouts on. I don't know enough about networks to be able to, I think, adequately describe what was timing out in some of these network switches. So you keep knocking out these timeouts and bumping them up, and things were still failing all over the place. So of these biggest customers that we're showing, some of them couldn't just find a way to get their data out. One of them, if we waited about 4 hours, the data finished coming out after about 4 hours for one of them. So when I started getting involved in this as a database person, I was very suspicious about how well that middleware layer was actually performing in all of this. And the way I go about it is kind of a guess and check and trial and error sort of methodology. So when I learned that the middleware layer was pivoting data, then I got extra suspicious. So what if we just had the database pivot the data? Teach the application developers how to use the database to pivot data. Has anyone ever heard of this? Did I get this right? Table func extension in Postgres. So this extension that is packaged with Postgres has this function called crosstab, and this pivots data for you. So I can kind of make the query fit on the screen just to give a rough idea of the extra SQL writing work that you'd have to do. The little SQL in bracket might be your SQL statement that just pull all the data out so that they come out in the one line per row for each attribute, but you shove that in there. But otherwise, what you wrap around it is using that crosstab function to spit the data out the way that you want to see it in the spreadsheet. Are people in the mood for guessing more numbers? How much? No, just want to see it. Yeah. So, all right, got the data back out of the system by just cutting out that whole middleware layer, doing all the stuff outside of the database that the database should be able to do.
So you were exporting the database through a middleware layer, not just like using a dump?
Oh, it was querying the data basically without doing any kind of I'm trying to think of the best way to put it. It wasn't trying to do any transforming of the data in the database. It wasn't really dumping, but it is a fair way to think about it. It's like join all the three tables and just let it spew out all the rows, joining that the entity value attribute table.
So then were you like, the result set that they were getting had like a row for every entity for every attribute, whereas after you just cross-train, you get a row for just every entity with all the attributes as columns, so that you already like did that?
Right, correct.
So you get like significantly fewer rows, and you're not transforming all those rows in memory in Python.
Right. But so it worked, but now we're looking at 22 minutes instead of seconds. That's still kind of a big, but it worked, right? So things were working, but there was still some trade-offs. How many folks use ORMs? One of the things that we learned now is that we couldn't use the ORM. I think SQL Alchemy was being used, and I don't know if this is still true today. To give an idea, when did I do this? It was roughly about 10 years ago. So this experience is roughly 10 years old. So instead of being able to use the nice models and stuff that the ORMs let you be able to use as a developer, now you got to write the raw SQL to do all this work. As a minor inconvenience, some of the customers that only had like hundreds of customers, well, it took a few seconds longer, but I don't think they noticed. But overall, we could still get, overall it's still slower, but at least it worked. We're looking at minutes now instead of seconds for these customers to get their data out. We did a little more testing just to see how robust, if you will, using the crosstab, using that table func extension was. So kind of making up data, making up some customers. What we found that we knew that this was, again, going to stop working when we got closer to, if we started getting customers closer to 5 million members that they were tracking. The way that the response times curved up was still closer to an exponential curve as opposed to a flat one in how long it took to export data. So we felt we needed to try a little harder to do that. Now, to the question earlier about whether a column store was ever considered, I think the question was asked more broadly. Well, some of the folks were like, "Wow, do we really need to use a database then? Can we just have this data somewhere else?" So I entertained that question a little bit. I was like, well, we can prototype another data model. We'll just prototype in Postgres since we just have the database available. So one of the types of data models that some of the folks in the company were interested in exploring was doing something more like a key value store. When I look up this customer, get his name. What is the name of this person? How it should be that simple. It should be simple enough to use a key value store to do that. So to entertain that question, how many folks have heard of the HStore extension in Postgres? So very, very simple extension to use to get a key value store type of functionality in Postgres. Some of the things about it, though, is that it handles everything in strings, so we will lose some of the strict type checking. If it's a date, you need to do a little bit of extra work if you really wanted to make sure that it's a proper date. Same thing about numbers, in case someone might have entered something that really wasn't a number that should have been, things like that. But we're just kind of prototyping things. We want to see if it's even viable. So before diving into the HStore stuff, we recognize some of that. We recognize we couldn't do any strict integrity constraints. And at that time, I don't know if this is as true today, some of the ORMs might not natively support using something like an HStore, a key value type data type within Postgres. So that just really meant that you have to do more raw SQL instead of being able to use some of the nice Python classes modeling that you'd get. So this is what HStore physically looks like if you were to transform that data to use the HStore extension. You'd have a table. You basically have two columns in this case. I'm kind of oversimplifying a little bit. You'd have your identifier for what the member is. In this case, I'm using the person's email address as their unique identifier. And then this column, call it whatever you want. I just called it HStore to signify that. That's where it's a HStore data type. So in here you'll have first name, and the value of that, the key first name, the value of that is well, my first name, last name, very database, and so on. And this is something that you don't have a strict schema to, so you can think of it as a schemaless, free form type of data type. Just to throw this on the screen to give an idea of how much this changes the query. Yeah, it gets a little bit longer. I can shrink the font and kind of get it on there to just give an idea of how much more complex the query is to query this data in a way that it'll spit out one person per row with all their attributes. Similarly, we can use the copy command again to dump all of that out into a nice spreadsheet, CSV formatted spreadsheet. Much simpler. You do have to add a line for each attribute that you want to dump out, but it feels a bit cleaner to me than even the crosstab function once you get past the other data transformation. All right, does anyone feel like guessing anymore? Yeah. Yeah, so it didn't, for whatever reason, I didn't time it on the other customers, but for the one customer that was generating 700,000 rows, sorry, it's that funny. For the one customer had 700,000 members that they were tracking. 5 minutes. Okay. What jumped up to 4 hours, down to 10 minutes, we're back down to seconds again. I think it still might be a little slower than just dumping the single table out, but we're in the same ballpark finally again as the original data model. So the lessons learned, the additional things that we learned was that please try not to use the EAV data model. No one should have to go through that experience again. It is usable for small amounts of data, but if this kind of scale at having hundreds of thousands of rows is even remotely possible, that's enough that should deter you from trying to use the EAV data model. One of the other things that I didn't get into was there were similar problems with getting data into the data model, not just getting data out of it. If you can, try to have the database do any kind of data manipulation as opposed to doing it external to the database. It really can do things pretty fast. The disk usage is kind of interesting. Using the EAV data model actually increased your data footprint by 50%. 1 terabyte, having 1 terabyte of data originally to a terabyte and a half. I think today, in today's hardware, is not a huge thing. But another thing, if you do know you've had tens of terabytes of data, that scale will certainly influence that. But the other thing that I think should be some relief is that if you do have that EAV data model now, there are ways to work with it, or to at least get by with it in hopes that you are trying to find a way to get off it into another data model. And at this time, the JSON data type wasn't quite implemented, and I think there are probably some other niceties that you can have with the JSON data type in Postgres, such as indexing and to some degree some strict type checking. And my expectation is that if you were to use JSON instead of HStore, I expect the experience to be more or less the same. And that's my story. Thank you for listening. I have a couple minutes for any extra questions if you like. We do have a Postgres table in the Expo booth too, in case you want to ask then too. Yes.
I want to apologize in advance because this is shameless self-promotion. I would urge you, if you ever get a chance, to check out Lotus Petal Architecture as a UI which may provide benefits for abstraction of very large data sets. I know we're usually most comfortable just putting a number on data, but depending on the speed of your connection and the bandwidth available, there are times when a terabyte may feel like a gigabyte, and vice versa. I think the only real advantage that a visual 3D model such as this one yields is just letting you have a relative sense of the size of the data. In theory and in actuality, this structure can represent an infinite amount of data. There are no limits. Of course, zooming in and getting to something that's actually applicable and feasible to represent is another matter. Essentially, it has 3 rings, and they're high, middle, and low. So that's enough about that. You can also visit www.lotus.fm to see some real-world implementations and some short videos explaining what this is for. And it is open source.
Cool. Thanks.
Thank you.
All right. No more questions. Happy to let you guys go. Thanks.